All right, so today we're going to continue on database design. We started last time designing this database to model films, actors, and directors. And we started with our first table, and then we'll continue from there all the way through this design, and also maybe some entering in some test data as we go along here. Remember that we are online, so if you have any questions, go ahead and post to Piazza and or to the YouTube live stream. Otherwise, let's go ahead and remind ourselves where we had got to last time. We're creating a table first for the film, to model films. We're using upper camel casing for our table names, and we're keeping them singular. We're using lower camel casing for our column names, and we've identified several types here, for example, integers, varchars, doubles, etc. Right? And we left off with, well, first of all, let's go back to this Internet Movie Database rating right here. There could be like a new release, right, where nobody's rated it yet, or it's in production or something like that. As it is right now, in contrast to, say, Film ID, where it's not allowed to be null, the default of each one of these is it is allowed to be null, right? So, for example, suppose the title, should that be allowed to be null or not? Should a movie have a title? Or if it doesn't have a title, what does that mean? Right? It hasn't been named yet. It has a working title maybe, right? It could be changed later on. But let's go ahead and put in a constraint there that says, no, we do not allow null. Right? In contrast with the Internet Movie Database rating here, it's also, it is being allowed to be null because it hasn't been rated yet. But we can also put in a default of 0. And we'll just say that if it doesn't have a rating, when you enter in this data, a default will be provided for you. So if you provide, the rating as 7.5, that's fine. That's great. It'll use that value. But if you enter in a new record with no value specified, then it'll take over the default here. It's still allowed to be null. It's just that you can change it to null later on if you want to. When you enter data, when you insert data, it'll take on this 0.0 value as a default, right? Again, you can use any numerical value here at all. -1 wouldn't make much sense. If you want it to be null, if you want the default to be null, then you make it null. But that's the default anyway, so you wouldn't write that, right? So let me go ahead and put it back to 0, 0 here. We also talked about the EIDR. Remember what that was? I forget even what that stood for. Does anybody remember? EIDRs. EIDR. Right. Universal Unique Identifier for Entertainment Registry, it looks like. Okay, I don't know where it was. Entertainment Identifier Registry. Right, there we go. That's what it is. So it's an external identifier. And I asked you to think last time, we've got two ways of identifying a movie or film here. We've got our primary key, and then we've got this external EIDR, okay? Do we really need two ways of identifying something? Yes, no, maybe we do want this. The motivation that I'm going to give you is to think about, say, a course enrollment system here at UNL. How is a student uniquely identified? How are you uniquely identified here at UNL? An NUID, right? Now, do you think in the history of the NUIDs, we didn't used to have those 20 years ago or so, so they were introduced the last 20 years or so. Do you think in the history of NUIDs or social security numbers or any other identifiers, ISBNs, EIDRs, nobody has ever screwed up and issued the same NUID to two different people and or issued two NUIDs to one person? It's hopefully it doesn't happen that often, but it does happen, right? When somebody else screws up and it's on them, well, fine. But should that control our database? Right? Should their screw-ups screw up our database? I don't want that to happen. So what I'm going to do is I'm going to create a buffer zone between these two entities. If you do not have any control over how the external keys are created, that control should not be exerted on your database. So what I've done here is I'm going to keep both of these as identifiers. Right? The film ID, that will be auto-incremented, generated, and managed by the database. Right? There is a guarantee that there will never be a duplicate film ID here ever. Right? And I will keep the EIDRs. And if they do screw up and say, oh, okay, well, Dune got 1, 2, 3, 4B. We actually meant for it to get 1, 2, 3, 4C instead. Okay, great. I will go ahead and change that one value in that one column in that one table. Whereas if I had used this all over my database for foreign keys, for primary keys, for everything else, right? And there is a subsequent external change, that means that change has to be permeated throughout all the tables that touch that data. Right? Whereas if I only keep it as an external key here, right, then I only have to change one column, one value, one table. Right? Much better design. Now, this is called a surrogate key, right? Because it's artificial, right? It's an artificial key that's created by the database, managed by the database. An EIDR or a social security number or an ISBN or something like that, that's called a natural key, right? Natural key. And it's okay, in fact, it's a good practice to have both of them in there. Again, if you have no control over the external key, then it should not control you, right? You want to keep those two things separate. This is a surrogate key, this is a natural key, you want them both. But for the integrity of your database, you'll use that surrogate key. Now let's take a closer look at this EIDR here. Is it in fact guaranteed to be unique? It's just a varchar like the title, right? I could have two films named Dune. In fact, there are 2 films named Dune. The 1984 version and the 2021 version. I think it was released last year, right? So those are allowed to be duplicates, right? EIDRs, though, should not have duplicates. How can I ensure that there's not a duplicate? I can put a uniqueness constraint on it. First of all, I'm going to make sure that it's not null. Not null, right? Because if it's a key and it's allowed to be null, that's kind of weird because one entry in my database could have that as a key, null, but no other entry could have that. So if you're one or nothing, why allow it at all, right? So not null, and then I'm going to put a unique key on it, right? In fact, I think I'm going to go ahead and move this all. In fact, I think I have to move it all to the end. There we go, and I have to spell unique correct. There we go. Huh. All right. So let's read through that. An EIDR is going to be a varchar 255. So it's big enough to hold whatever it is. Of course, if you want to go back and count up exactly how many characters there are in an EIDR, you can make it exactly the size that you need. It's not allowed to be null, right? And it's going to be a unique key. It is not a primary key. A primary key is unique to, and a unique identifier for every record in that table now and in the future. This is what's known as a secondary key. Secondary key. Right? You can have as many secondary keys as you want. You can even make key combinations. That the combination of the title and the EIDR, that must be unique or something like that. Right? We're just going to go ahead and keep this one column as unique. If I tried to enter in Dune 1984 and Dune 2021 with EIDR 1234, 1234, right? Those are distinct films, and it would reject that data with this unique key. Without that unique key, you would be allowed to enter in 1234, 1234, 1234 as many times as you want for all EIDRs. Okay, good. What else do we want? Anything else? I think that's all I've got for a film. So let's go ahead and take care of actors or directors. Directors? Okay. So now technically one film can have multiple directors, right? I think Sin City had like 4 directors. There are rules that say that you can have, there is a maximum number of directors, the Director Film, or Film Actor Guild, Directors Guild, et cetera. They have all these union rules about what can and cannot happen. But we won't worry about that. We'll model the fact that one director can direct multiple films, and one film, or a film, only has one director. So what kind of relationship is that? One to many. One being one director has many films, right? One film is by one director, though, right? We're just going to keep it simple. If you wanted to go the other way and make it so that one director can direct many films and one film can have many directors, right? Then you would have some sort of a many-to-many relationship. We'll do that with actors, but I just want to keep it simple for directors. So let's go ahead and create a table, film, or a director. And tell me semantically what a director is. Before you tell me anything about what a director is, what's the first thing that should come to mind on every single table? Director ID. A way of uniquely identifying every record in that table. Director ID. Int primary key, not null, auto increment, done. Right? You've got second normal form for free already, and we'll talk about that at the end of the day. All right, now tell me what a director is. A name, okay, which is a varchar 255. So Denis Villanueva, or whatever his name is, right? Or Villanueva, comma, space, Denis for Dune. So just a name, first name, last name. I like that way better. Right? Because in the future you can have middle name, you can have suffix, you can have prefix, right? You can add all those things in that you see in a regular web form, okay? Both of those varchar 255, 255, right? And that's good enough for a director, okay? How do I bring these two things together? Right? How do I show that a film has been directed by this director and a director directs these films, right? A foreign key, right? And so what is our relationship here? What is the parent that has the, and who is the child that has the foreign key referenced back to the parent? One to many. So in this case, who's the child? Film is the child. So let's go back up here and add another column, director ID. Right? Why did I name it after the primary key over here in the director table? So that they would match up, right? This ID matches that ID over there. If you use the same name, there's no guesswork whatsoever, okay? It's going to be an integer. Why? Because the primary key is an integer, right? You can't go, you have to compare apples to apples and oranges to oranges, not apples to oranges. If I made this a double, does that make much sense to match it to a key that's an integer? No. All right. Okay, int. And should it be allowed to be null? Not null. Okay. Why? Because do you allow orphans? If you want to allow orphans, then fine. Go ahead and make it nullable. Right? Now you can have films that you don't know who directed them. Right? Maybe you want to model that. If not, then go ahead and put in that constraint there, not null. Okay. Now, do you see the keywords foreign key here at all, bridging these two tables together? Nope. We have to put that in manually. And the way that we do that is, funny enough, foreign key, right? It does what it says in the box. Director ID, right? And that's going to be the director ID in this table. The foreign key is this director ID. And what does it reference? It references the director table, right, director table, and in the director table, it references the director ID. So it's kind of like reading in plain old English here, right? The foreign key, I'm designating the director ID as a foreign key, and it references this table down here with this ID, right? That column in that table right there. And that's how I bring those two things together. All right, this is a pretty good start. Let's go ahead and try to execute this entire script now. I'll go ahead and try, oops, nope, that's cut, enter. There we go. I don't want that. Oh, here, I'll get rid of this for now. All right, and what's the problem? Create film table error. Can't create this film table. Why? Foreign key constraint incorrectly formed. Okay. So, within this film table up here, does the director table exist yet? No. Where did I create it? Down here. Right? So order matters. In order to reference a table, guess what? That table has to exist first. So I'll just move it up there, okay? I'm already using the database, so let's go ahead and let's show tables again. It might have gone down and actually created the director table. It didn't. The entire thing failed. So let's try it again. I'll go ahead and get rid of this so it doesn't show up. There we go. Green, green. We're all good, right? In fact, let's show tables now. I've got the director table and I've got the film table. Right? What does the director table look like? Well, it looks like exactly what we just created here. Right? And there's a film table. You can actually use describe. I don't know if I showed this before, but describe film. And it'll show you exactly how you created it. Right? There's a title, release date, IMDb rating, EIDR, and director. Whether or not it's a key. There's primary key, PRI. There's a mul, which is a foreign key. Whether or not it's allowed to be null, right? Default values, if any, and any other extra things, right? And of course, it's type right here, describe. I can describe director. Right? And I get the same thing. Well, different. Okay. I'll go ahead and leave that in there so when I cut and paste it, you'll have it. All right. Actor table. Let's go ahead and create an actor table. What's it pretty much going to look like? It's going to look almost exactly like a director table. So for my first iteration of this, let's go ahead and make a separate actor table. Can directors be actors? Yeah, Quentin Tarantino. Well, no, I mean, I'm talking in real life. And can directors be actors, and can actors be directors? Yep, actor, right? There we go. So should these even be different tables? Because directors are people, actors are people. Right? We have kind of an object model in our head right now, right? Actors and directors are both people, right? And sometimes actors are directors and directors are actors, right? So maybe you have an argument here that you shouldn't have two separate tables. Maybe you should have just a person table. And then that person table is going to end up being a director in some cases, maybe an actor in different cases, right? And you could greatly simplify this with only two tables. I'm not going to do that because I want to actually show you all tables here. But that would probably be a better design, arguably. And then you could also argue, well, what if I want to subclass those, right? Because you are working in object-oriented programming right now. You are doing subclasses, say assets. How do you do that in a database? Right? There are several different solutions, and we'll go over those later. But the best solution that I'm going to give you is keep it simple. There should probably only be one assets table. How do you distinguish between a stock and a cryptocurrency? You use what's called a discriminator column, right? That's what we did in your CSV files. How do you determine whether or not an asset is a stock or a cryptocurrency? There's an S or a C, right, in one of the columns. Right? And that's what you'll probably do eventually in your database. If you find yourself doing that in your classes, you're probably doing something wrong, right? Because you probably should be having a stock class and a cryptocurrency class, or crypto class, whatever. Right? Okay, that was just an aside. Otherwise, we've got actor, actor ID, first name, last name. How do I bring these two together? Right? So what's the relationship here? Many to many. One actor can be in multiple films, and one film maybe have multiple actors. So I've got a many-to-many relationship here. How do I bring those two together? How did I bring games and platforms together? With that availability table, that join table, right? So let's go ahead and create a join table to model a many-to-many relation between actor and film. So I'll create table. Okay. And what should we call this? Got film and actor. In the video game database, we called it availability because that was the verb. This game is available on this system. This system has these games available, right? This actor acted in, right? This film starred this actor. So those are okay verbs, right? Or you can keep it simple and go film actor, right? That is an adjective and then a verb, right? Or then a noun, right? Film actor. Bring those two together. You could have called it acted in, right? Or you could have called it had star, right? Those seem awkward. And if you're joining this table to that table, might as well just take the table names and combine them, right? Film actor. There. All right. What do I do first? What do I always do first? A primary key, right? Not null, auto increment, integer. And name it after the table, film actor ID. There we go. Okay. Now, what else would I put in there? Two foreign keys. Why two foreign keys? Because I'm bringing together two tables. A film ID and then an actor ID. So, film ID, actor ID. And because they are both foreign keys, it's going to be int, not null. Int, not null. And I'm going to define two foreign keys. I'm going to go ahead and steal this up here. Foreign key, actor ID, references the actor table and the actor ID in the actor table. And then the director or film ID. It doesn't have to match the same order, but I'll change it so it does. Film ID. There we go. Move it up there, put a comma. Now I'll have two foreign keys, one that references one table and another that references a different table. Right now, this is arguably what's called a pure join table, in that it only exists and it only has data bridging the gap between two tables. With the video game database, we didn't have a pure join table. We had additional data that said that when this game is available on this system, it was published in this year, right? If I didn't put that in the join table, then the date would have to be in one or the other tables, which would prevent the same game being published in different years on different systems. Or if I put it in the platform table, then that would really be screwed up, because then it would say that all games were published in the same year on that one on Switch or something like that. So, what kind of data could be associated with a film being in an actor being in a particular film that's unique only to that relationship there? I don't know. Oh, nobody watches movies anymore. Literally, nobody's watched a movie in the last 2 years. No? Nobody's going to see Batman? And the role, right? Their role, right? Which could be a varchar, right? 255. What's his name? Vampire Kid. Vampire Kid plays Batman, right? So this could be whatever Vampire Kid's name is. Okay, Vampire Kid is better. Robert Pattinson plays Batman in this particular film, right? Right? Or you could say, have a Boolean, right? Is Oscar nominated, right? And this could be a Boolean. We haven't covered Booleans, but you can put Booleans in here, and that would be set to either true or false, right? You could put a whole bunch of stuff in there. Ultimately, at the end of the day, it's going to have some C-style type erasure. Yes, there are in like Postgres. I think that it's a little bit of a stronger type, and 0 and 1 might be rejected. I'm not sure. And of course, there you can also configure, I think, a collation or your query to marshal them into a particular type. So if it's 1, it'll be true. If it's 0, it'll be false. And then anything else, that's an error or something, right? And then also there's an issue with tri-valued logic too, because it could be true, false, or null. I don't know, right? And then when you bring it into code, what happens to that null, right? Now you have to use a big B Boolean in Java to model that. Right? All right, I'll go ahead and just put in role though, right? Varchar 255, right? And maybe we don't know what their role is. And so we'll just go ahead and leave it nullable. Okay. And thus optional. All right. Let's run this entire script again. Build everything top to bottom. Failed. Why? Error code. Director already exists. Remember, we successfully created it. Well, okay, I want to wipe it out. How do I drop tables? Drop table director. There we go. All right, let's go ahead and try that again. Still failed. Oh, that's right. Oh, did I not execute that? Undo. Drop table director. Oh, I couldn't drop the director table. Why? It referenced it was referenced by the film table. Okay, fine. I'll go ahead and drop the film table. Done. Then the director table, green, green, and now I can run the entire script again, right? Yes. But what if I'm doing this over and over and over again because I'm iteratively developing it, making sure that everything works, everything is syntactically correct, right? Always drop it, then always recreate it. Or drop table only if it exists, right? So that if it doesn't exist and you try to drop it, right? If I try to drop table foo, right? There is no foo table. That will end up being red, no, because that's an error. That table does not exist. But if I put an if exists, it will work no matter what, right? Let me go ahead and drop film, right? Or drop director. Right? Yeah, I can't do it because cannot delete yeah, I've got the other two are what? Drop table if exists, actor, and then drop table if exists, film actor. There we go. So drop that, then drop the actor, then drop the film, then drop the director. And everything's been dropped. Right? If I do it again and again and again and again, it's no longer an error. Instead, it is yellow. What does yellow mean? What does yellow triangle mean? Yeah, warning, right? Isn't that what a yield sign looks like? Or is it inverted? Is it inverted? Yeah. So then I don't, why the hell is that a warning then? Whatever. It's a computer warning, okay. Who knows where these icons came from, right? Eventually we'll have generations that don't know what that disk icon means, or the origins of the disk icon that means saves. They'll just know that it saves, right? But otherwise, this needs to be in order, right? If I'm going to create a film that references director, I need to create the director first and then the film second. Likewise, if I'm going to delete it, I need to delete it in reverse order. So delete the film table first, then the director, then potentially the actor. So where does this one belong in all that? I created it last. So if I'm going to drop it, where should I drop it? First. It has to be the reverse order here. Right. Now I can run the entire thing all in one shot. Right. Green, 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 green. 4 tables created. And I can start to put in some test data. If I'm going to put in some test data here, where do I need to start? Can a film exist without a director? Let's go back up. Can a film exist without a director? Nope. Can a director exist without a film? Yeah. So let's put in some director data and then associate them with a film. Insert into director, values, first name, last name. And note here that I'm not doing a director ID. I guess we could do the director ID because this is test data, so I want a little bit more control over it. I want to be able to reference that other director without having to do these complex nested queries. So what I'm going to do is I'm going to go ahead and just hard code those primary key values, at least for my test data. Okay. Denis Villanueva. I think that's how you spell it. I'm not sure. Doesn't really matter. All right, another one. I think I said Quentin Tarantino. Forgive my spelling, but whatever. Give me another one. I don't know who directed the new Batman. Oh, the new one. Okay, let's put Tim Burton in there. 3, Tim Burton. Hopefully Michael Bay didn't do it. Did he? Oh, he did? Oh no. Yeah, the new Batman, which was supposed to be year 1. Batman, new film director. The Batman. Director, Matt Reeves. Oh, thank you. You really scared me there for a second. Oh, hopefully. I mean, Vampire Boy is trying to redeem his acting career. Has been for a while. All right, so there I've got some directors there. All right, let's insert into film. Film ID, because I will probably want to associate some actors with it. What else is required for a film? So the title is not allowed to be null, so that's required. A release date, though, I don't need to put that in there because it's not required. IMDb. The default will be taken over for me, so I don't need to put that in either. An EIDR, however, I do need to provide that. And a director ID, I need to provide that. So film ID, I want to provide that because I want to associate it with other records. Title, and EIDR, and director ID. So 4 things. Title, director ID. I even forget what the EIDR. EIDR, and I'm just going to make them up. We're not going to actually be forced to look up all these actual EIDRs. All right, so film ID, I'll start those at 10 so I don't confuse myself. And the title, The Batman. I'll just go 1, 2, 3, 4. And then the director ID for that was 5, Matt Reeves. Right. I'll go ahead and go with just contiguously here. Batman, the 1989 version, right? In fact, I'll go ahead and go 1989 as the EIDR, ABC, so that you understand that those are not actual numbers, right? And Tim Burton directed that. Give me some, just a few more films here. I guess Dune, right? For 2021, bar. And that was directed by Denis Villeneuve. Is that how you spell Villeneuve? Denis Villeneuve. All right, fine. There. Come on. Give me some films. Michael Bay. Whoever said Michael Bay, you got to give me one film. Transformers. All right. Not bad cops. What's the Will Smith movie? Wasn't that Michael Bay? Or the Rock or whatever it was, right? Alcatraz. 999. There we go. And that was directed by Michael Bay. Right. ... However many you feel would qualify as a non-trivial test case. Right? If you have 5 directors, some of them might have multiple films so that you can test that. Some of them might have 1 film. Some of them might have 0 films. So for example, Quentin Tarantino, I won't put anything in under him just to make sure that I'm getting that one-to-many relationship here. But I do not have any directors here that have been repeated. So tell me what that cop film was. Bad Boys, right? That was Michael Bay. 3333, whatever. And that's also Michael Bay. Can't believe we have 2 Michael Bay films in here. Right. Values. There we go. Oh, and then I don't have an opening bracket there. Okay. All right, let's go ahead and execute this entire script over and over again because I did have a bunch of drop table if exists. That'll save me some time. Operand should contain 1 columns. Where we insert into director values. Oh no, did I screw this up? All right, no opening curly bracket. Oh, no, opening bracket. No bracket. and no bracket. All good now. Let's try again. There we go. All right, so you do not put in brackets there. Sorry. Right. But lining them up like this, right? Very, very nice. In fact, you can probably imagine yourself, doing this in an Excel file and then dumping it to a CSV file and then converting it over to SQL. If you used any tools on your first phase for generating data, those same tools can be used to generate SQL queries to do stuff like this. Or you can take your CSV files and then put them through some sort of a converter to generate SQL test data like this. Right? All right, let's make sure that it works by selecting everything from film F, join director D on D.director ID is equal to F.director ID. And verify that we have all 5 of these films successfully in our database with all of the relevant directors in there. Right? All right. I'll leave that down there so that we can verify that other things are correct too. All right, other test data. Insert into actor. What do we require for an actor now? Oops, up here. An actor, well, actor ID is not required, but I am going to put it in there so that I can make a connection to it without having to query and then find out what was the auto-generated key, what was, I don't want to have to, or do a more complex nested query. I will go ahead and hard code those. So, insert into actor. Actor ID, first name, last name. And by the way, did I do first name, last name, or last name, first name? And does it matter? Nope, as long as you are consistent about it with respect to your query here, right? The ordering of the columns is irrelevant. The ordering of the rows is irrelevant unless you put an order by clause in your select statement, okay? So all I have to do is make sure that I'm consistent here. So here I'll go ahead and start at 100, right? And the last name, I don't know, Patterson? Robert Pattinson. All right. There we go. And Robert. Okay. Give me another actor. Something associated with the data that we have here. You say what? Wilson? Well, who's Wilson? Oh, Will Smith, sorry. All right, Smith. And Will or William, who knows? Who's his weird son? Willow? Or one of them? We'll put them in the database, but then we'll make sure that they're not in any of our films. Right. What else? 103. Who else is in the Batman? Oh, okay. Let's go with Jack. Nicholson Jack. And just to make sure that we have a or a multiple association, who played the original 1989 Batman? Michael Keaton. Michael. There we go. Now let's associate all those records with respect to the, well, actually, let's go ahead and, what's wrong with you? I don't know why that's griping, but values, thank you. There we go. Now it works. Now insert into film actor. Right? And I'm going to want to associate all 5 of these with at least one of these films over here. And in this case, do I need to worry about the auto-generated key? Do I need to hard code that? Not unless I'm going to make reference to it somewhere else, and I'm at the end, right? I'm just doing these 4 tables for now. But I do require the film ID, the actor ID, and let's just go ahead and put in that role, okay? So, actor ID, film ID, and role. Values. Let's see, actor ID, Robert Pattinson 100, acted in The Batman 10 as Batman or Bruce Wayne, right? 101. Oh, we don't. Will Smith acted in Bad Boys 14. Some cop. Right. 102. Oh, we decided not to give him any rules. So 103. Jack Nicholson starred in Batman 11 as. Oh, does it? Oh, here's a good quiz. Is it Joker, of course, but what was the actual character's name? No? Jack Napier? Oh. Or the Joker, fine. 104, Michael Keaton was also in Batman as Batman. There. All right. Run that all, and we're all good still. All right, let's see if some of our, now for test data, sometimes you do want to do ad hoc testing. So for example, what I mean by that is, remember that we have this other constraint up here that the EIDR had to be unique. When I inserted all these films, I made sure that all of these were unique. Let's go ahead and ad hoc test this to see if that constraint is actually working. And we see that it is. Right? It errors out down here with a duplicate entry of 1989 ABC. Okay. You don't put that in your test data because that would fail out your entire database creation. Right? But you do test it ad hoc, like once, okay, that works, and move on. Right? It's a sanity test. Okay. That all looks pretty good. I guess we could flatten the entire data model and make absolutely sure that everything works. Join director D on that. Join actor or film actor FA on FA.actor ID or film ID is equal to FA.film ID. Right? And then join what was it? Actor A on A.actor ID is equal to FA.actor ID. There we go. Say what? Film actor FA on. I'm going from the film to the film actor. So yes, sorry, that's why we got a 0 result. Film actor F or F. There we go. And FAA. That all looks good. All right, come on. The entire thing. Come on. All right. Oh, that's why. It's sitting and spinning. No. It's doing what it did on Tuesday, unfortunately, it looks like. Anyway, while we're waiting for that to fix itself, am I going to get all the records that I put into the database with just these regular joins? Nope. What do I need to do? Left joins to preserve records. Now, strictly speaking, I don't need to go left join on a director. Why? A film cannot exist without a director. But if I want to go the other direction and capture that one director that we made sure Quentin Tarantino had no films, then what else do I need to do? Same thing, but with right joins. Trying to reconnect. There we go. Nice. Finally, let me clear this out. There we go. Right joins, right joins, right joins. And if I want to join them all together into one big giant query that tells me that I got everything in there, union them together. Run the entire script. There we go. We've got everybody. Right. You'd go through, of course, and make absolutely sure that this is the expected result. And when you're satisfied that all the films are there, all the directors are there, and for example, Willow Smith over here doesn't have any other information in the entire database. Where's Quentin Tarantino? Oop, we're missing him somewhere, but that's okay. I'll let you debug that. Okay. Probably because we started the film, then went over to the director, then went over. So we probably have to start at the director and then go over the film. And we can do that really quick since this is going to be in your notes. Film F and then a right join on that. There. Now where is Quentin? There he is. Right. Quentin Tarantino is now preserved. Right. So 5 unique directors, 5 unique films, 5 unique actors. Okay. Good. Now what I want to do is I want to make it look pretty. Right. So let me go up and create a new model. And then go over to File, Import. And I'm going to reverse engineer the script that I just wrote. And it's on my desktop. It's right there. And I'm going to make sure that I click that button right there. Place imported objects on a diagram. Execute. Blah, blah, blah. Continue. Close. And, ooh, I've got a nice picture here. Move that over there. Move that over there. Move that over there. Move it around. Make it look as nice as you want. Whatever you want, however you want to make it look. I like them both on top, so there we go. And then there. Too far. And then a little bit of skew or something like that, or directly over, right? Or above. And you've got an ER diagram, an entity relation diagram, that anybody who knows database stuff can look at this diagram and immediately, in fact, they could probably take the diagram if it were in some form and generate the script that you just wrote. Right? They would certainly be able to rewrite the script that you wrote. Primary key, I can't zoom. I can, over here. Primary keys are designated with this little key up here. Whether or not the box is filled in tells you whether or not it's nullable. If it's not filled in, it's allowed to be null. If it's filled in, then it's not allowed to be null. Likewise, foreign keys are red. Right? It tells you what the type is: varchar 255, varchar 50, etc. A double, and it also tells you the relationship between these two. If you hover over it, in fact, it'll tell you what the foreign key is that defines that relationship. ER diagram, generate it for free, put it in your design doc, and you've got your bonus points right there for the design doc at the end of the semester. Not only that, but it saves you from writing about 2 pages of text describing your database. Now you can write maybe 4 or 5 paragraphs describing why your database is the way that it is, right? That we have a film table because we wanted to model films. We have a one-to-many relationship here because we didn't want to model the fact that multiple directors can. We wanted to keep it simple, right? We wanted to model the fact that there is one director per film, right? Yes, we do realize that there might be a future need for modeling more than one director in a film, but Yagni, we ain't going to need it yet, right? Those are the kinds of things that go in your design document, right? Now, the requirements are dictated to you in the project handout. What you need to be doing is rewriting those requirements and then justifying your design back to those requirements. Okay. All right. Questions on that? And by the way, that's not, you can take a snapshot of this, or you can, I think you can export it as a PNG. And foo.png. What does it look like? Where's foo? Come on. It looks however you set it up. If you want to, you can go back in, change it, and then take another snapshot of it. Right. Okay. Questions on database design? No? So again, it's on the video, but the steps to do that, I'm not going to save it, but the steps to do that are new model. Once you've created a new model, you can import and reverse engineer a script. Make sure that that checkbox is there, and it'll generate it for you. That's also on the tutorial videos too, I believe. Okay. So those are some of the things that we went over implicitly throughout the entire thing. You can use unique key to create a unique constraint on a column or columns. Right? The foreign key foo references table bar can be used to define foreign keys, etc. Right. Let's talk a little bit about normalization. So, these are design principles when it comes to database design. There are actually 4, 5, 6, and beyond normalization forms. We're going to keep it simple to the original 3 normal forms. There's 1 normal form, 2 normal form, and 3 normal form. And they build on each other. So something cannot be 2 normal form unless it is 1 normal form. Right? Something cannot be 3 normal form unless it's 2 normal form, and by transitivity, it also has to be 1 normal form. Right? So what are these normal forms? They're just general guidelines that say your database is a proper normalized relational database management system if it conforms to these ideas. First normal form is that each attribute, that is column, in a table only has atomic values. So what does the word atomic mean? Other than, you know, atoms and an atom bomb and stuff like that. What's the original Greek word mean? Indivisible. Atomic means that you can't break it up. Now, of course, we called atoms atoms before we knew that you could break them up into, you know, neutrons and protons and whatever else, and those can be broken down into quarks and other subatomic particles, etc. Don't worry about that. Every column in a table holds only 1 value. Right? It is atomic. You can't break it up further. Right? Now, to understand this, it's easier to understand what violates normal form. So here's a violation. Right? If a column has, say, multiple values using some delimiter. For example, email 1, comma, email 2, comma, email 3, comma. Right? Does that look like a relational database management system piece of data to you? That looks like a flattened CSV file to me. Right? What is the relationship here? One person, if you want to give them multiple emails, what should you do? Have a one-to-many relationship between two separate tables. Another violation would be simply creating multiple columns for multiple fields. Right? So, for example, columns, email 1, and email 2, and email 3. Right? It wasn't too common, but we saw this kind of pattern even in Java classes. Like, no way. That should be a list, right? Why would you not want to do something like this? Somebody that only has 1 email, guess what? Their 2 other columns are always null. Right? Somebody that has 2 emails, that 3rd column is always null. And by the way, if you delete an email and then you replace an email or whatever, how do you know which email column to look at? The 1st, 2nd, or 3rd? Look at them all. Then pull the data into your Java application, check for null for all 3, and then compile a brand new list. Right? You're doing extra work for no reason. Whether if you had normalized it to begin with, then you wouldn't have that problem. Not only that, but what if somebody has 4 emails? Are you going to change your entire database, add a brand new column just to accommodate this one weirdo with 4 emails? Right? Nope. Normalize it. Split it out into multiple tables and relate them through a foreign key. Right? Second normal form. It is both first normal form, 1NF, and no non-prime attribute, again, attributes mean columns, is dependent on a proper subset of prime attributes. Don't worry about this, because if you have a primary key auto-generated, you get this for free. You do not have to worry about what this means at all anymore if you follow this good practice. What does it mean, though? So that you can see what a violation of it looks like, consider the following. What if I had a purchase record that had a customer ID And that purchase was located at a store, and so it has a store ID, but it also had a store location, like an address. The Lincoln GameStop? No. Yeah, okay, yeah, GameStop is a thing, right? GME, right? Okay. I was thinking gamers, and they went out of business, then they reopened, went out of business, reopened again. All right, let's go ahead and go with GameStop. Somebody buys a used copy of Splatoon at the Lincoln store, right? That customer has an ID, that store has an ID, but then also we're encoding Lincoln in that record. Right? Should that be in that table? Is that the only purchase record that's going to happen at that GameStop in Lincoln? No. So what are we going to have? We're going to have like 10, say they did 10 sales, right? Then we're going to have Lincoln, 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 Lincoln repeated over and over and over again. The whole point of a relational database management system is to remove redundancy. Right? And so this would be a violation of second normal form if you are encoding something that does not matter. Right? The identifier here is these two things. The customer ID and the store ID, that creates that purchase record. This customer purchased something at this store. Right? The store is a separate record that should be in a separate table. It is only dependent on the store ID, not the customer ID. Because the customer can go up to Omaha and purchase something at that GameStop, right? Yeah, it's called GameStop, right? Okay. All right. Third normal form. It must be second normal form. And therefore, by transitivity, it also has to be first normal form. Quote, no non-prime column is transitively dependent on the key. Okay? So just so we make sure that we understand, what is transitivity? A goes to B and, do we know this? Wedge. There we go. And B goes to C. Right arrow C. There we go. Do we know the wedge? Otherwise, I'll go ahead and replace it with just a regular old text RM. And, right? The wedge is the logic way of expressing the and, right? So if A goes to B and B goes to C, then what do you have to have? Then A, here, text RM. Then BA goes to C. There we go. There. So A goes to B, B goes to C. Therefore, you can go from A to C by going through B. That's transitivity. So what does that mean with respect to attributes? Suppose that you had a price per unit and a number of units. Right? You were selling stuff at GameStop or something. Right? You have a price per unit and number of units. What is the total price? What is the total cost? The total cost is equal to the price per unit times number of units. Right? Do not store the total cost. The total cost is derived from the other two. It is transitively dependent on the other two. You store the price per unit and you store the number of units, but you do not store the multiplication of those two. You pull those two out and you multiply them. Or you formulate a query to multiply this column by this column to produce a report. If you did store the total cost, guess what happens? You have now a potential for a data anomaly. What if they change their order to, instead of 5 copies of Splatoon, now they want 2 copies of Splatoon, because they realize that nobody needs that many copies. But they do need 2 copies for some reason. Right? Your total cost has now changed. Right? That change may or may not permeate over to that other column. So don't store that column. There are weird things that you can do. You can design triggers and cascades and stuff like that in your database. It's something that I'm not even going to cover. But you can take care of stuff like that. Just don't put it in your design. It's not a very good idea. It's a violation of third normal form anyway. All of these are, you can remember this using the mnemonic. So I swear to tell the truth, the whole truth, and nothing but the truth, so help me God, right? That thing that you say if you go up on the stand. Every non-key attribute must provide a fact about the key, first normal form, the whole key, second normal form, and nothing but the key, third normal form. So help you cod. All right? Who's cod again? Maybe I didn't mention it. Yep, he's the guy that created the relational model. Edgar Cod, 1970 at IBM. Right? So, again, every non-key attribute must provide a fact about the key, the whole key, and nothing but the key, so help me Cod. Right? And that's what normalization is all about. Right? At the end of the day, normalization is semantics dictate design. You start thinking about what you want to model, and then you start thinking about the relationships between these entities. And that naturally gives you these tables. Right? And if you start designing tables and you start refining them, you'll eventually get to this no matter what. Right? But these are guidelines that you can check out and see, oh, well, no, that violates third normal form, or that violates first normal form, or something. Okay? Questions? Otherwise, I'll make sure that you have the database that we just built in your notes. And we can talk, finally, about miscellaneous stuff. Although I'm thinking I want to save this for next time, maybe. Right? There is a lot more about databases. Actually, yeah, we've got 10 minutes, so we can go through them. Triggers, views, stored procedures, variables, loops, right, etc. SQL is what's called a declarative programming language. It is a programming language, but it's a declarative language. It declares what it is. Did you see any variables here at all? Did you see any loops? Did you see any what's called imperative style, like C or a little bit of Java, where you say, I'm going to create an index variable, and then I'm going to iterate over these values, and I'm going to add it each time, right? You specify every single step of the process, right? You didn't specify any step of the process here. You specified that, say, this query is what it is. I'm going to select these things out, and this is my result set. I'm declaring it to be what it is. It's kind of like another declarative programming language that you are familiar with is Excel. Excel, I want this cell to be the sum of these 4 cells over here. Did you write a for loop to do that? Did you create a variable to hold intermediate results, the first one, then add the second one and put that into sum, then add the third one to sum, then add the fourth one to sum? No. You just declared that this cell is the sum of these 4 cells over here. Right? Now, it looks like you did call a function because you called the sum function. Those are macros. No, that's not a macro technically. I don't know what they would call that. But you do not have those things necessarily in SQL. You can have variables. You can have loops to an extent. I'm not going to cover it, but if you want to read all about it, then go ahead and pull up a tutorial on it. I tend to leave this stuff to the actual application layer. If you're doing too much business logic and this kind of stuff in your database, that's a code smell to me. That you're probably doing too much, you're doing business logic in the data tier, and when you should be doing it in the business tier. We'll talk about multi-tier architecture later on. Right? Triggers are things where if this column gets updated, then perform this task over here. And the most common thing I've seen with triggers are to keep a log of the last time somebody changed or somebody logged in. Right? So you check their password. When you check their password and it passes, then you also put in a date timestamp, the date of the last time they logged in or something. Or the last time they changed their password, you have a trigger that automatically updates a date timestamp to when they did that. So that you can go back and look at those things. You don't have to write application code to do that for you. You can define what's called a trigger. Stored procedures are basically functions. You can, if you've got a really, really complex query, that you do one query to formulate a result, do another query to formulate a result, and then you bring them all together. You can do all that complex logic and put it into a stored procedure that then you can query out that stored procedure instead. Views are a way of getting a read-only view of the database. If you want to, for example, if you've got one application that's reading from the database and it should never, ever write to it, right? Then you can give it a view of that database, and now you have a guarantee that any attempts to write to those tables are going to be rejected. And then another application is allowed to both view the data and change the data. Right? It also is a security thing. If you've got, say, 5 columns, but one of them is a password column or a social security column, but you do want to allow somebody access to the first name and last name, you can create a view that doesn't show these columns over here. And from the query end, it looks like the table only has these 3 things over here instead of all 5. Very, very nice way of granting access, limiting access, and preventing changes. Another aspect that we're not going to cover are transactions. Well, we'll cover it with respect to JDBC later on, but transactions are how you interact with a database. They are an all or nothing thing, right? What you can do is you can have a series, say, of 3 queries. You do the first one, everything's fine. You do the second one, everything's fine. But the third one, that one violates some constraint, right? There's a duplicate EIDR or something like that, or a duplicate ISBN or a duplicate social security number. What it'll do is if you wrap this up into one transaction, it rolls back all the way to the beginning like the first 2 never happened, right? So if you have an all or nothing thing, if you've got one query and you want it to execute or not, then there's your transaction. But if you have 3 queries because you want to put all this data in and it all depends on each other, you wrap it up in a transaction and make sure that it all happens or none of it does. And it either commits, right? Success equals commit, and failure means rollback. Right? All the changes are rolled back. Right? And that's a transaction. Transactions guarantee the ACID principles. I don't know if we talked about those, but it's atomicity, right? Consistency, isolation, and durability. There we go. Atomicity means that it's an all or nothing thing. Consistency means that before and after your transaction, all of your database rules, the constraints, the foreign keys, the primary keys, any unique keys that you have on it, they are all satisfied before and after a transaction. Somewhere in between the transaction, those could be violated, but there's going to be a guarantee that it all happens or none of it happens because of atomicity. Right? Isolation means that one transaction and another transaction, they don't step on each other's toes. They happen in isolation. And durability means that in the event of catastrophic error, the database will come back up in a consistent manner. All the rules that you define in your database will be enforced. Those are the ACID principles. Right? You also have, of course, security issues. Right? Where to store passwords, how to grant access or restrict it, right, etc. Usually, database administrators don't like to think about it, so they'll put their database server behind an entire database server and their application server. They'll put them behind firewalls, and they'll let them talk to each other, but it won't let let the database server talk to anybody else, and nobody else will be able to talk to it. And if you put it behind a firewall, you have that guarantee. Thankfully, our 3306 port is not firewalled. We've had to fight for that so that it stays open so that you can say, go back to your dorm room and still connect to your database. But otherwise, most ports are shut off by default nowadays, and you have to have a reason to open them up. Right? But how do you store passwords in a database? You don't. You let somebody else do it for you, right? That's why so many websites, you can get in with your Google credentials or your Facebook credentials or something like that. They allow, they offload security and keeping track of passwords and identification. They let somebody else handle that, right? UNL does the same thing. We use a shibboleth, SAML, S-A-M-L, which is a single sign-on service. The reason that you can get into so many different services with one password, your UNL password, is because they use a centralized authentication server. Your one exception, of course, is your CSE hand-in. because that uses the CSE credentials instead. So yeah, if you did actually have to store passwords, never store them unencrypted. What was the last hack that released passwords? The last major one. I forget. What? NVIDIA had one? All right. They were probably hashed passwords, though, at least, hopefully. They were not storing actual passwords. They were storing encrypted, hashed versions of the passwords. You can still look up, common passwords, like, I wonder if anybody's password was password, right? You can hash the password and see if anybody was using that password, but you can't reverse it because of how hashing works. If there is ever a data dump where all the passwords are stored in plain text, you definitely know something definitely went wrong there. Right? All right, so that's security issues. You also have what I like to call soft versus hard deletes. All right. So a hard delete would remove a record using the delete query. Right? A soft delete would make a record inactive using, say, an isActive Boolean column. Now, why would that be a good design? I'm not going to say that you should design it like this. In fact, I would discourage you to design this in your databases because it's just a class project. But think about a real application. And somebody goes in and deletes their stuff, right? Do you actually want it deleted or not? Maybe, if there's a privacy issue, right? I think that there's been a push to delete Facebook, right? There's a secret, though, that even if you request a deletion, if you ever go into it in the next 6 months, it will be restored immediately. And then you have to request deletion and then wait another 6 months. So if you request that your Facebook and all of its data and everything get deleted, they don't delete it for 6 months. They do a soft delete, right? Why? Because, well, they want you to come back to Facebook. But why would we not want to have a hard delete? We would lose the data, period, right? So for example, you could say a user, an IDT 10 user, comes in and deletes all the sales records for the last month. Oopsie, right? Even though you had designed your application to say, are you absolutely sure you want to do this? Yes. Are you really sure you absolutely want to do this? With another dialogue pop up, right? And they say yes again. Okay. If it's a hard delete, all that data is gone. If it's a soft delete, they call you up and said, I screwed up. Yes, they actually have a physical, one of the old school phones, and that's just because that's who they are. And they say, well, I screwed up, and all that data, we need to restore that. I don't know if I can do that. That's why I put that button there that said, are you sure you want to do this? And then the second button, are you really sure that you wanted to do this? Why did you do that if you didn't mean to do it? Right? And you can berate them and then say, well, I'll see what I can do. And then you take your time, do whatever, go get some coffee, do whatever you're going to do, wait a while, and then restore it by simply just resetting active to true, because the data was never really gone. Now you're the big hero, right? And by the way, I'll send you my bill for 20 hours minimum of consultancy on that at $350 an hour. $350 an hour. Right? So you're the hero if you have soft deletes rather than hard deletes. Right? The first time you use it, it pays for itself. Right? The last thing I'll mention is where we'll pick it up last time, that an OOP model is not the same thing as a relational model. OOP has functions and inheritance and polymorphism. A relational model does not. A relational model is just pure data. Right? It's like a Java class that has no functions at all. So how do you resolve the differences between these two models? And we'll cover that next week. Okay? All right. Have a good weekend.